This entire unit focuses on solving systems, and then today, specifically, we're going to solve them by graphing. Now, when I say a system, it is referring to two different linear equations. So here we have a graph, two different linear functions, and the solution is the point where they intersect. So we can see here they intersect at the point 1, 1. So 1, 1 is the solution to that system. So we're going to be using that idea throughout this entire unit. Now, in this unit, there's a way to always check your answers. Check to see if it is right or not. So the first examples is basically showing you how you can always check your answer if it is correct. So what the question is saying is the ordered pair meaning 2, 5, a solution to this system? In other words, if you were to graph these two equations, would they intersect at the point 2, 5? And we're going to figure that out not by graphing but algebraically. And the way that we can do this is every point has an x and a y. So we can plug the point in for x and y into each equation and check to see if it is a solution. So first, y equals 2x plus 1. If we plug in x and y, it will be 5 equals 2 times 2 plus 1. 2 times 2 is 4, and 4 plus 1 is 5. So 5 equals 5. That is a good sign. That's saying that this point will be on the graph of that equation. Now let's check the other one. It has to be a point that lies on both of the lines. So 2 times x, so 2 times 2, minus y, which is 5, does it equal 8? So in this case, 2 times 2 is 4, and 4 minus 5 is negative 1. Negative 1 does not equal 8. So therefore, that point is not on the second equation, which means it is not the point that in which the two lines intersect. So to answer the question, is the ordered pair a solution to the system? And in this case, no, because it doesn't work for one of the equations. Alright, let's check one more together and then you can try one on your own. So same idea, we have two different linear equations, 4x minus y equals negative 12, and negative 6x plus 5y equals negative 3. And we have to try to figure out, is the point negative 4.5, negative 6 the solution to that system? In other words, does that point lie on both lines, therefore is it the intersecting point? So we're just going to plug in negative 4.5 in for x, negative 6 in for y, and check to see it has to work for both equations for it to be the solution. So here I rewrote the two equations, but I plugged in negative 4.5 in for x and negative 6 in for y, and now we can simplify. So to simplify, 4 times negative 4.5 is negative 18, and then minus negative 6 is going to be plus 6. Does that equal negative 12? And yes, it does. So negative 12 equals negative 12. So it works for the first equation, but it has to work for both for it to be a solution. Negative 6 times negative 4.5 is a positive 27. And then 5 times negative 6 would be negative 30 equals negative 3. And 27 minus 30 is negative 3. And negative 3 equals negative 3. So that means that this point lies on both equations and is therefore the intersecting point between them. So is the ordered pair a solution? In this case, yes, it is. Okay, here's the last example. Y equals negative 3x plus 5 and y equals negative 4x minus 1. We need to find out if when you graph these two lines is the point negative 623 the solution. So go ahead and pause the video and try this one on your own. You should find that this point works in both equations. Therefore, it is the intersecting point of the two lines. So, in this case, yes, the ordered pair is a solution to the system. So just remember, throughout this unit, we're going to be solving for the ordered pair. And then to check if your answer is right, you can always plug it back in and see if it works. Now we're actually going to solve a system. So here we have a system, which is just a set of two linear equations. X minus y equals negative 3 and 3x plus y equals negative 1. So we're going to graph both of these lines and find the point at which they intersect. So to do this, I'd say easiest way is to solve them both for y, get them in slope-intercept form. So for the first one, negative y equals, I'm going to subtract x to the other side, so negative x, and I have a negative 3. And now divide everything by a negative 1. So y equals a positive x plus 3. So let's graph that line. We start at the y-intercept of 3, and then we have the slope up 1 over 1. And now for the other equation, let's solve it for y. So y equals, subtract 3x to the other side, so it's a negative 3x, and then minus 1. If we graph that, we're going to start at negative 1. And then the slope is negative 3, so I'm going to go down 3, right 1. And then to go backwards, up 3, left 1. So when you're doing this, it is important that you're very precise with your lines. And mine is off just a little bit, but if you connect this, I know it's not perfect on my graph, but they do actually cross perfectly at the point negative 1 up 2. So negative 1, 2 is the solution to that system. And remember, you can check, let's see, is negative 1 plus 3 2? Yes, it is. And if you plug in 2 here, is negative 3 times negative 1 minus 1, 2. It is. So therefore, I have checked that negative 1, 2 is the solution to my system. Okay, same thing. Here I have my system, the set of two linear equations, negative x plus 2y equals negative 2, and y equals 1/2 x plus 3. So I want to graph both of them, which means they need to be solved into slope-intercept form. This one is already solved, so I can graph that one right away. My y-intercept is at 3, and then my slope is 1/2, so I'm going to go up 1 over 2. And then make sure to go backwards, you can go down 1, left 2. Alright, so I've graphed that. Now the blue equation, let's solve for y. I'm going to add x to the other side. So 2y equals a positive x minus 2. And now we have to divide everything by 2. So y equals x over 2. You can really think of it as 1/2 x. and then minus 2 divided by 2 is 1. So if I graph that, I'm going to start at negative 1, and my slope is up 1 over 2. Now, what do you notice about the slope of these two lines? You should notice that they have the same slope. And if two lines have the same slope, which is 1/2, it means that they are parallel, and two parallel lines never intersect. And the whole point is to find the solution to a system, which is finding the point where two lines intersect. So if they are parallel, then that means that there is no solution to the system. Alright, here is our last example. We have one equation already solved, so I'm going to go ahead and graph that. Y-intercept is at 4, and then my slope is 3, so up 3 over 1, or down 3, left 1. So graph the line, and now I just need to solve the other one. I'm going to add 12x to the other side, so 4y equals 12x plus 16. And now I'm going to divide everything by 4. So y equals 12 divided by 4 is 3x, and 16 divided by 4 is 4. So if I graph that, you notice these two lines are the same. So when I graph my blue line, it is on top of the pink line, which means it is intersecting at every single point. And since these lines go on and on forever, there are an infinite number of solutions because the two lines are intersecting at an infinite number of points. So when you are solving systems, the two linear equations will intersect at one point, which means there is one solution, or they will be parallel, so they will never intersect and there will be no solution, or they'll be the exact same line and they will intersect at every point, which means infinite solutions. So there is your first lesson on linear systems, and this one's solving by graphing. Good luck with the lesson.